Hello, everybody, and welcome to Hop to It, Innovating Easter Egg Delivery with Ververica Cloud Live webinar, presented by Alexey Novokov, a solution architect with Ververica. Our webinar today should last approximately about 1 hour, and then with the Q&A session. The recording will be provided to everyone who registered by the end of the week. Please post any questions you have in the chat or Q&A during the webinar. And with that said, Alexey, please go ahead.
Thank you, Spencer. Before we start, a few words about me. So I'm a product solution architect at Ververica. I'm working with Apache Flink daily on different topics. I'm also a software engineer in the past, so sometimes I contribute to open source projects, and I also like to play music. So for today's webinar, we've come up with this agenda. So first we will outline the story of our Easter Bunny, the project of the Easter Bunny, the scope and goals, the architecture, how it was developed, the implementation, and what's the result would be of the implementation, which is dashboard. Then we summarize the whole webinar and the solution, and we'll then finish on the Q&A session. So let's start then. The first part is the story of the Easter Bunny. So we are right before the Easter holidays, and you might know that for every Easter, parents may hide the Easter eggs for their children in different places, in gardens and other locations. So this time as well, our Easter Bunny, who is our hero of today's story, was working for a long time to improve their Easter egg delivery. And I met this guy, so I met the Easter Bunny who had implemented very significant and outstanding system for eggs delivery. And he told me that actually he used some very interesting technologies, and one of them is Apache Flink and Ververica Cloud as well. So we sat down with Easter Bunny over several drinks and a cup of coffee and tea, and try to implement this whole system one more time to see what actually was the secret source of this story. So what was the innovation there that allowed Easter Bunny to make all children happy right in the city where the Easter Bunny operated in. Okay, so he explained me that the task was the following. So there is a city where the Easter Bunny and his team needs to deliver eggs and for the children. So there are multiple locations where the children are expecting their eggs, and there is also a single place where the egg factory is located on the bottom, the left bottom corner. And these locations are connected to the egg factory by different streets. And the challenge was actually to bring all those Easter eggs very fast to the children, to make them happy, do not frustrate them and not allow them to wait for a long time. And there is also a fixed number of bunnies. The team is fixed who can deliver the eggs. So that was an interesting task to automate that and to also use streaming technologies to bring all the eggs to children as soon as possible. So the constraints of all this challenge that Easter Bunny has told me is there are 10 unique bunny delivery drivers, so we can't use more. There's always some fixed number of bunnies. There are 12 unique locations where the eggs needs to be delivered. Every location is located and it has own distance from the egg factory. Egg orders, which are coming from children, they're requesting them. It's an infinite stream of orders, and egg production also takes some time. And the delivery of egg depends on the location and the distance, also how far this location from the factory is. Okay, so let's move to the second part, scope and goals. The ultimate goal of the entire challenge is to make children happy. So he wanted to deliver all the Easter eggs to the location as soon as possible. So how he achieved that? And then we decided, okay, let's also implement that. So the key was to use Ververica Cloud, where you can run very easily Apache Flink applications. Also, the main idea or the goal to achieve the goal was to minimize the delivery time. So the dispatching of the egg orders needs to happen as soon as possible, so without any delays. And in order to control that and monitor and tune when needed, the end goal was to build a dashboard, a real-time dashboard, which can show how our delivery, how our business is operating. So scope of work, in order to achieve that, we would need to connect to data sources where the data about the Easter eggs orders is coming from. We need to design the dispatcher algorithm, translate it into the set of Flink jobs, also implement several SQL queries to monitor delivery process, and also visualize all of that in Grafana dashboard. Okay, so let's look at the architecture. As part of the whole architecture, we came up with this set of events which we would need to process in order to deliver the egg. So there are 9 unique events which start from when the new order is created. Then once order is in the factory, egg is ready. So there's another event for that. Then there's a set of purple events, colored in purple. The allocated bunny, increased traffic, decreased traffic, and the allocate bunny. This is events which are created when we need to basically use our resources, which are the fleet of bunnies and our city map, where we need to also take into account the traffic so that we cannot just allocate any bunny at any time. And also when the order is moving through the life cycle, it changes its status. So it has, at the very beginning, it has new status, then egg is ready, order is shipped, and order is delivered is kind of final status of the order. This is this green boxes. And contextual events, which are always happening concurrently to any order, this is that some bunny has changed its location and traffic for some road is changed. That's the set of events that we came up with. Also, there is one more diagram that we prepared with Easter Bunny, which just describes all in detail the whole process, how to make this challenge, how to automate that, everything regarding the delivery process. So we ended up with a bunny pool that we import the first time, the set of bunnies that we have for delivery. Then the child creates an egg, the egg order. So let me maybe just pause that. And that order comes into the message queue. Where you can see that egg orders message queue. That's the very first event, new order, and that's consumed by a first Flink job, which is called egg factory service. So that egg factory service, so we decided to just implement as a simulation service. This is a Flink job that just consumes new order, and then at some time emits the new event, says that order is ready. So that's number 2, egg is ready. Let me just, I resetted the animation. So just going from the very beginning, coming back to the point where we left. So we have an egg is ready event. Then after some point of time, the comes into play the second service, which is called order dispatcher. That's the main algorithm of our system that egg bunny is the bunny that came up with, where the order dispatcher has taken the event egg is ready and does something with it, but it's not only taking that event, but also other events from the context. That's the city routes and bunny locations, those initial data of bunnies and initial data about the city. So once it has this data, it can produce other events. So those other events are actually about their shipping data. So order dispatcher is allocating a bunny, it sends event to the bunny locations, also increasing the traffic, right? So it notifies the system that this route is now taken. So you need to take into account that as well. And after that, it returns back the order in next status, which is called order is shipped. So there's a shipped status. After some time, dispatcher notifies, monitors the bunny, and deallocates the bunny. So there is another event, number 5, deallocate bunny. So it's releasing the resource into the system and also decreasing the traffic. So it's also makes another contextual event. And there is one more third Flink job service, which is coming into the play, is that delivery service. So once the order is shipped, it also monitors that event. And once the shipping is done, it just simulates that the bunny has delivered something, that egg, and then sends the final status for the order. Order is delivered to the system. That's an entire story on the architectural view. So what happens with the whole events and how we're going to process them, right? So there are 3 Flink jobs that we're going to implement and several message queues, which will be Kafka topics. Okay, let's move to the next slide. I just go, yeah, need to come back to here. Okay, the complete workflow of all our system can be visualized in a way that we start everything from Ververica Cloud, and we take data from AWS Kafka. Then we prepare the results, prepare the analytics, and sync it also by Flink to AWS MySQL database, and that will eventually be in Grafana dashboard. So in the Grafana dashboard, so what we will have, that's going to be one of the main control mechanisms where the Easter Bunny can decide, yeah, what's going on with our delivery. Is it good or bad? Is it slow, fast? And maybe do some corrections after looking at this dashboard. One of the question to the dashboard that will be taken is that order fulfillment. So we need to visualize how many open orders, orders in progress and delivered we have currently at the very moment. Delivery duration. So we want to also know and analyze how fast we are dealing with current orders, like what's our average duration of order when the order is submitted and then till the egg is delivered. Another question, orders per bunny delivered. So we want to also know whether our bunny are utilized in a fair manner. So if all bunnies are used and not only 1 or 2 out of our fixed amount of bunnies. And one more chart is egg demand per location versus bunny current location. So we want to know which location is requesting more Easter eggs than others. And we want to see also where the currently bunnies are located. That's also we want to provide this data to the Grafana dashboard and then visualize that, all these questions. Okay, let's go to the next part, which is implementation. Before we start in Ververica Cloud, we need to connect the workspace in Ververica Cloud to the data sources. We need to create private connections. So one of them is the connection to the Kafka. So we just need to provide AWS IAM rule that allow us to use your specific MSK cluster managed Kafka from Amazon. And we'll also say which endpoints, which host names, brokers, they will be used in this connection. Then we reference these brokers in our Flink SQL code or a Flink jar-based deployments code as well. So in Java, Scala, or any other language. We can also connect to any other system, not only Kafka from Ververica Cloud. That could be Amazon S3, different tables like Payman, Hudi, Iceberg. It could be MySQL databases and much more. Okay, let's design our table for orders. So in order to simulate some orders, in order to create some data, we are going to use Faker data connector, which is generating for us new orders. So they are these orders will be placed into this similar table, and they will all come with status new, and the location for order, this will be one of this value, which you can see in this line. So the location could be bank, pet store, fire department, or any other. So if we run this in Ververica Cloud SQL editor, we can see, okay, that's what the data will look like eventually in the Kafka topic once we insert it into the respective table. For real table, which is just called orders, we just take that orders gem table and insert from it into the Easter orders table. So that's the definition of the orders table. You can see here now the connector is called Upstart Kafka, and then we specify also the broker, the Bootstrap servers, the hostname where we insert the data. Okay, for other topics, for other data sets, we also generate some data. And the second one is routes. So you can see here the SQL code, which we can write in Ververica Cloud SQL editor in order to launch this as a deployment, as a SQL deployment, and insert this data into the another Kafka topic. So this one is for the location route. We can see here that the structure is something like a key to the list. So every location contains also an array of streets that needs to be used to reach this location. For example, in order to go to the bank, we need to go through the mail, Vernon and main streets, and so on and so forth for other locations. We also insert this data. So this is just a static list. So insert into the location route topic or table. And the third one is the bunny locations, which is going to be dynamic topic, dynamic table, where these bunnies changing their location. So we just insert their names, their list, and with the event time now. We don't insert location, so location is going to be null by default. So there are two fields inserted. So we also run this in Ververica Cloud as a SQL deployment, and that's going to be inserted eventually into the stable bunny location. You can see 3 fields will be populated by this SQL deployment. So we have 3 deployments. Once we start them, we now can switch to the next part, the dispatcher algorithm and all what's related to the jar-based deployment for this solution. So what kind of jar-based deployments, which you can write with help of the Flink data stream APIs, we decided to do. There are 3 of them. So you remember on the diagram we had 3 Flink jobs. These are 3 mains. Those SQL data preparations are on the side, and also we'll have other SQL deployments for the monitoring for the Grafana dashboard. They are not in this list. So these are the 3 that we would implement also and launch in Ververica Cloud. This is the Scala code, which I used with Istabani to map also the same tables that you've seen in SQL to the case classes. So that's the same data structures. They have the same fields and similar types to simulate that in Scala. So eventually for the first service, which is just the egg factory, which takes the order and then translates and changing the status into the egg is ready after some time. So we implemented very simple data stream based Flink job, which reads from Kafka topic. Then after some period of time, it groups these orders simulating the production of F eggs. So there we simulate that we need some time to prepare the egg, which was requested by a child. And then we sync that right back to the topic with different status. So there is some 5-second delay, 5-second window that is used to produce these eggs and then send them further. So this is quite simple job. You can see also this is a print screen from Ververica UI showing the Flink job graph. There is a second most important Flink job, which is called order dispatcher. So it has a bit more, maybe more complex job graph. Yeah, it has 3 topics, 3 inputs. So it takes the data, besides the orders, it also takes data constantly about the bunny locations and the routes. So you can see here 3 inputs to the process function. The process function is quite complex. I think we may share the code and share the full implementation later as part of the webinar. So I encourage you also to look at the process function, how those conditions, what is actually implemented to do all these allocations of the bunnies and which events are going to be emitted eventually. But to summarize that, so we expect by this job that events in status egg is ready. So we join that with city routes and bunny pool information. We produce eventually the order in status shipped. And we adjust city traffic and bunny availability. So we also emit a couple of other events. So they are not shown on this graph, but they also, their job is also sending data into the locations topic and the routes, and the orders topic as well. A few more words about the dispatcher algorithm, so some highlights in the process function for this job. We used broadcasted state. For broadcasted state in Flink, the Stream API, there are two callbacks that you need to implement. One of them is called process element, and the second one is called process broadcast element. They take two different types of events, and one of them is process element order, the second one is delivery event. So this is for the first callback is actually for the mainstream of orders, and the second one for delivery events. These are the polymorphic type for two other events, which is the city routes and the bunny locations. So we process them in parallel, concurrently. So these are two sides of the stream. And in order to make a decision when we meet order as shipped, whether we can find some free bunny to allocate, whether we can put some delivery for a specific route, we maintain set of state variables in Flink job, which are the data stream API of Flink, and there's main state variables on the screen. So there's a couple of them, like map state for the location load. This is where we keep track of how loaded the specific location currently in order to make a decision which bunny can be taken for a specific route, for example. The allocated bunnies, the currently allocated bunnies by this particular task of a Flink job. Then if we cannot ship an order, we buffer them in a specific list. It is pending orders variable, you can see here, and two broadcasted variables, which are the information about routes and bunnies. So we are operating over these 5 variables in order to make a decision to make that solution possible, which I described on that bigger diagram, where we make a decision like what can be taken to ship the order further. All right, so on the third service is the delivery service, which is may remind you the first service, which is quite simple one. It takes an order in the status shipped, and then it simulates that delivery kind of delay, right? So the bunnies need some time to deliver the eggs, and then in 5 seconds, it sends the same order with next status, the final status, which is called delivered. All right, so that was the part about the jar-based deployment. So the main, let's say, core implementation of all this solution. Now we need to provide some data for monitoring. So we decided to do that by doing other Flink jobs, right? So for that, that's going to be a Flink SQL type of jobs. There are 5 of them in order to answer those questions that we wanted to have on our Flink dashboard, right? So those graphs like order fulfillment and others. So all reports are using mainly 2 tables, orders and bunny locations, and the results of these reports are written to MySQL database, and then the tables from MySQL database are used by Grafana to visualize the data from them. All right, then let's move to this part. Next one is monitoring dashboard. So what we eventually got is the real-time dashboard in Grafana showing 5 plots, which are basically describing the whole delivery process, currently what is going on, right? So what we have here is the undelivered orders per location. You can see here the names of locations from the city, right? And how many orders are still undelivered to a specific location. We can see that, okay, there is some place like River House has lots of orders and they are not yet delivered by some reason. Whereas in a location like Bowling, there are only 2 undelivered. So that's maybe a good question to ask to the system or to do something with the delivery. So why we have some locations so many stacked orders. Another graph that was also prepared by the Flink job is order fulfillment. It's just showing current picture of the delivery, how many orders were delivered so far and how many are in progress, still needs to be delivered, or how many just opened and were not taken into work. And the middle plot, which is showing this kind of time series graph, right? It's the order delivery duration. So we see that every order takes some number of seconds to be delivered. And this middle line, I think it's 10 seconds kind of threshold. And we see that we are on average about 10 seconds, but we may be faster or higher. So we may want to see that every time, whether we are not too slow, right? So if we would go up then 10 seconds or to 20 to 30, then something is wrong with the deliveries. We need to make some actions. Another two graphs are current bunny location, which we can see how our bunnies are moving across the city. So we have those 12 locations, right? And for example, here on this picture, we can see that 7 bunnies are currently on the egg factory. That means they are not running in the city, they are staying on the factory. Maybe they are stuck somehow. Maybe they don't have orders, and there is some bug in the system where they cannot be allocated. But that's also a good indication that we need to do something with that. And the last one, number of eggs delivered per bunny. So we have unique bunnies, like different names for them, Ares, Artemis, Bucks, and so on and so forth. We can see they are delivering eggs uniformly, right? So they are all utilized into the same amount of orders. They all deliver pretty much the same amount of orders. There is no, there's something, some of them is running a lot or like delivering everything, but all others are just resting somewhere. So that's what we ended up building with Estebani. And that actually was the key to success for the whole Easter delivery. So he was able to monitor that and in the real time and make corrective actions, and eventually all eggs were delivered to children. So to summarize that, so the real-time dashboard allowed Estebani to watch key performance indicators and adjust the system to be more efficient. Okay, so we moved to the summary of all of the entire webinar, but then maybe I can also show a couple of live dashboards as well. So before doing that, let me summarize what you can take from the story, and what kind of other use case you can build out of that. So you probably noticed that this could be generalized into the more higher context. The whole idea of this egg deliveries is basically could be adjusted to the any goods delivery, right? Think of any shipping services like DHL, USPS. So where you have fixed number of drivers or some kind of fleet of drivers, right? And you need to efficiently use them to deliver something and monitor, whether some of them is still working, functioning or not. So this is something you could do with this solution as well. Adjust it and think how you can apply to your similar use case. Manufacturing lines. Among our experiences with Ververica, so we have clients who are asking us like how you can apply Flink or Ververica Cloud for the manufacturing, for IoT, for example. And the stories they're describing are also can fall into this category of the delivery. So let's say into the task where you have constant stream of some kind of parts that you need to the manufacturer to build, right? And you have fixed number of machines. You need to coordinate these machines in order to take new parts into them and build some kind of bigger parts out of those smaller parts which are constantly coming into the plant, into the factory. So that could be also applied in this context. And as I mentioned, the whole thing is about the shared resource pool. So you have some kind of fixed number of resources of some type, drivers, bunnies, cashiers, robots, and you need to utilize them evenly, to just have a bigger coverage and satisfy your kind of service or business. That's also about this story as well. So takeaways from Ververica Cloud itself. You can run all types of Flink jobs on it. So you can run a jar-based deployments, Flink SQL deployments very easily. For the Flink SQL application, you can prototype, deploy, and adjust your Flink SQL code anytime from Ververica Cloud UI itself. So it's quite conveniently to do that there. You can adjust from many different data sources that you may have in cloud already, on the public clouds. And Ververica Cloud allows you to scale down and scale up your deployments anytime you want. As for the technical solution for this story, right? So a few highlights on the Flink API. You've noticed that we used both, let's say, APIs, right? So the Flink SQL and DataStream API. Many developers who are finding Flink and Flink SQL try to use it and apply as much as possible, right? To cover all tasks, all solutions, use cases. But at some point you may see that, you need more fine-grained control or low-level control. So you can always fall back into the DataStreams API, where you can use JVM languages or Python to implement your stream processor. So that's doesn't contradict to the Flink SQL itself, right? To the idea of trying to use a more high-level language, so you can use both APIs successfully. All right, so maybe before we go to Q&A, I'll just quickly show a dashboard that I have here, which is live and running. So I'm currently still letting the system to run to produce the orders and bunnies to run and deliver the eggs. So you can see here, I have a Grafana dashboard, which is showing me the statistics, right? So where I have all those graphs which I described to you. I have this 5-second refresh, I believe, here, and I also can refresh it myself anytime to see that the data is moving here, right? So what might be interesting right now on this picture, that for some time I was running the system and I see that 2 bunnies were overutilized. For example, the Ares and Pushinka, they were utilized quite a lot. You see, they delivered more than 1,000 orders, whereas other, like a half of that. So that could be a question to the system. So why these 2 were overutilized? Maybe there is some bug, right? So that's one thing that allows you to see in real time some issues and to correct them, right? What other interesting points here that, okay, after some refresh, right? So I see that Egg Factory has lots of bunnies there. So that means they're not running, they're standing there and they're not delivering orders. This could be okay or maybe bad situation, because what I see right now, from order fulfillment perspective, I have 5 in progress orders and 1 open. So quite a few, not that many. That's probably the reason why most of the bunnies are on the Egg Factory, because there are a few only needed to match this 5 in progress orders, right? To cover them, so we don't need the entire fleet of bunnies. So that's probably okay, right? So then you can, over the time, you can find other patterns, right? To look at this diagram, to this dashboard and fix something in the system. And I think I just wanted to show one more thing about these queries. We will go to the Ververica Cloud, and I'll try to show some of the queries which I have for the monitoring dashboard. So I'm in my workspace in Ververica Cloud, where I see the list of all deployments, list of all Flink jobs, which I developed with Easter Bunny for this Easter egg delivery problem. I think there are around 11 of deployments some of them for data analytics, for SQL reports, for Grafana, some of them for data preparation, and some of them for the main core solution to process the events for the delivery. So in order to, for example, you want to first develop some analytics query to see some aspects of your delivery, but before you sync this data into MySQL, into the Grafana, you want to debug that, right? So that's quite logical question. So let me pick up one of these queries, for example, the delivery duration, or maybe a bit shorter one. Okay, so I have, let me just zoom in a little bit. So I have a SQL query which is delivering data to Grafana for visualization purpose. It is Bunny assignment. So this is the query which selects the data from the Bunny locations, topic, table, and insert this data every time, on every event to the MySQL database. So let's say I want to edit it or just preview this query, right? So what can I do here? I just switch to the running deployment, SQL deployment. I can see its status over here. There's running. All the tasks of the Flink job are fine, right? So I can see some different statistics about the Flink job, right? So I can see the metrics, the records in, records out for this job. And I have a bunch of other information about the Flink job. So pretty much the entire Flink UI is right in this pane. But what I wanted to do initially, I wanted to edit the code for the MySQL query. So what can I do here is just I click edit. Even though it's running, I can still edit and debug in parallel, right? So maybe just one more zoom in for you. All right, so I have this query here, and I just wanted to maybe preview that. So what results it delivers to the sync table, right? This Easter Bunny assignment. That's the sync table, the target, but I have the select query. So I can just click debug and select my session cluster, which is already running in the system. I can run more session clusters, but I just use this one. And if I just let it go, I can expect that whatever is selected by this query is also would be visible in the UI in real time, right? So we just launch the same query against the data which we're operating, which we're processing on a site. So we just use session cluster resources to run this query and see actually what is delivering. So what it's inserting into the target table. So here, the specific query is showing the bunny assignment. So we can see that for every location, we have some amount of bunnies which are currently there at the specific moment, at the specific second of time. For example, the egg factory 5 means that there are 5 bunnies currently at the egg factory. So it is stopped. I just resume this query again. And you can see that the bunny mainly going back to the egg factory where they should wait for the next order. And sometimes those locations like River House or others contain 1 or 2 bunnies. That means that currently in that location, the bunny is delivering the order there. But I'm fine with this result. So, right, so I just don't want to edit. I'll just stop this. But if I edit it here, so I can just change any code and click deploy and then restart the job. This is how you would do any modifications for the query. All right, so I think that's mainly it. I probably go back to our presentation. And we are at the Q&A session right now.
Hi, Alexey. This is Karen joining back on you. So we did have a couple of Q&A that came through on the webinar chat private line. So I will happily moderate that with you. And then also, folks, for those of you that are watching, if there are any additional questions that come up, please don't hesitate to put it either in the Q&A or in the webinar chat as well. So one question that came up is, I think you mentioned it, but do you support jar-based deployments and Flink SQL?
Yeah, sure. As I just mentioned, for core Flink jobs, which are operating or which are processing the events, like all those new orders, shipped orders, there are 3 Flink jobs among the 11, I believe, implemented in Scala in JVM language, which is supported by Flink. You can use Java as well, of course. So yeah, in order to run that, in order to launch in Ververica Cloud, the jar-based deployment, you just simply go under the deployments. Then when you click create deployment, you choose that type, right? So this is the jar-based deployment. By the way, you can also use Python, PyFlink as well here. For jar-based deployments, you just select your jar file, which you can upload right away or in advance. And you can specify optionally the main class and the arguments to this main class, right? As well as the additional dependency if you want to keep them separately, other jar files as well. That's the way how you create the jar-based deployments. And for this another type, which is SQL deployments, you just you go from another way. You just go into the SQL editor and click new, and then from here you would create the SQL deployments from the screen. I think I might lose the session, but yeah, eventually you just select here the new script and then click next.
Great. Okay, a couple more questions that are coming in. What is the advantage of using Flink for this use case of deploying those Easter eggs?
Advantage of Flink that allows you to process data very fast, so in a streaming way. So you can process it and apply your business rules in any as in any complexity as you need. So if your business rules to process data remind something like we had, right? We need to take into account the city routes, bunny locations, I know weather, anything else. You may have different data sources there. Yeah, a bunch of different streams, and you might need to join them, right? So, and then in order to then process that and have the code for processing all of that maintainable, so Flink is the best one. So you can just apply here the Flink framework, and that's the fastest one across if we compare with other streaming technologies or frameworks. So it's a true streaming, so it doesn't do any mini batching, so just processing every record one by one from your stream, but it also supports batch, by the way.
Great. A couple more that are coming in. Are there any connectors available on Ververica Cloud?
Oh yeah, sure, of course. There are several connectors which are built in, so I can just show you as well. From the Ververica Cloud UI, you just go to connectors. You can see here the number of them which are already integrated, right? Elasticsearch, MongoDB, Apache Pymon, Kafka Redis, and others, as well as the formats. We have different ARA, CSV, JSON, other formats are also already integrated, so you don't need to install them. You can also install your connector. So if you need some custom one, you implement that as per the Flink API specification, and then you upload your connector as a file, as a jar file, into the system.
Great. Okay, is it possible to run Flink SQL on the delivery data to run some analytics?
Flink SQL on a delivery data to run some analytics. Yeah, of course. So on a delivery data, all data in our solution is coming from orders topic, right? So we have a table which we map onto this topic. So if I go to a data catalog where I registered all the tables, this is actually the main analytic you would run your SQL on top of that. So you can come up with any SQL queries and then publish this result into some report, into some BI system, right? So we use Grafana here, but you can also share this data through any other sync storage to BI tool, for example. That would be your solution here. So if I just want to show you that you can query this table anytime. So if I go to my drafts, which I have here, I have some script called Easter Sandbox, where I just have select star queries type of, and this delivered data is, as I said, mainly in the orders table. So if I just run debug in the same way I did for that one of the report, I can just see what the orders table has right now. So it's a streaming query, right? So it's showing you the constantly going streaming data in this query, in this table. So you can see that currently I'm observing the orders and the delivered status. And there are some orders which are new. You see they are popping up here, but then they change their status because the processing is going on and those orders are delivered. They change their status to delivered. And also this table has a primary key. So every order has a unique key. And by this key, we update actually the status. So you can come up with different analytical questions to this table and experiment in this editor quite easily.
Great. Okay, as generative AI is a hot topic now, I'm wondering if it's possible to train some models and answer reporting questions.
I think you can. It depends on what kind of model you would want to train here. I believe this data could be shared. The reports that we prepared for Grafana or any other reports could be shared to some storage where you would do machine learning, right? You would do some training for some model and then feed this result back into the system. So one of the case example I might think of is that if you have your model trained somewhere, right? So maybe some kind of Python environment, you could share that as well as a service, and then it could be called as well by the Flink jar-based deployment type of job, where you could have just enrichment of data through that stream, which is serving that model, right? So you could also engage in this story where you would, combine to the machine learning model. It would be exposed maybe as a service, and then you would just call it from your Flink chart-based deployment from any deployment that you would want to use it there. So yeah, why not?
One of the follow-ups to that was, for example, how many eggs have been delivered in the last 2 hours?
Last 2 hours. I believe for this type of question, I would rather write some SQL query that would just simply calculate that with a SQL code. I wouldn't apply any machine learning here. Only like if you really want to do that. So I don't really imagine this here. I think for type of work here or challenge that we've got, the AI could help maybe to rank something or rate, right? We have at some point we need to make a decision like which bunny to take and which city route is better to use. So currently this whole story is implemented on very simple rules. So, but you can make it more complex, right? Every bunny may have some specific strength, or like, let's say every bunny would be unique in terms of the speed or velocity. So it could have all metadata, all features, so to speak. And then, you could again, engage into some machine learning story to use that to have better decision-making process to just call that model, and then it would help you to make some certain decision in your Flink streaming job.
Okay, interesting. Let me see. It looks like there's one more that came in. How long has Ververica Cloud been available?
Yeah, it was launched on the Flink forward that we had in October on 2023 last year as general availability. But earlier to that, also in 2023 in spring, I believe in April, it was started at a beta version. So it's going to be, already since we launched that first time, 1 year, I believe, in April. Yeah, right, accurate by this moment.
That's what I remember as well. So, okay, looks like another question that's coming in. Will the source code be available for the attendees to check out offline? particularly and especially for the jar-based deployments.
Yeah, we can share that. Why not?
Okay, great. All right. I don't see any more open questions. I'm going to leave it for just a moment and see if anybody else has anything else that they'd like to add in. All right. Perfect. Well, Alexey, let's go to the next slide and give a couple more resources for everyone that joined us today.
Yeah, sure. Yeah, thank you everybody for the questions. Just a few more things I would like to add. I encourage you to try Ververica Cloud yourself, or we have a promotion with $400 credit where you can use it to experiment and start your streaming story, your journey into this world. And that, yeah, you could use that to write your egg delivery there, right? So to connect different data sources and use the whole all API of Apache Flink in Ververica Cloud. So I once again encourage you to try that and go to our website and go to Ververica Cloud registration page. And another resource, which is also would be, I think, beneficial for all of you who are interested in this topic, we have Ververica Academy. There are a couple of courses already, which is the Introduction to Apache Flink and Flink SQL, which you can try yourself, study that, right? So, and also we have all list of talks, all recordings of the talks from the Flink World, which we had in last year, right, in October. They're also there. You can watch them in your free time and learn lots of new things from the industry who is using Apache Flink, right? So that's I think very interesting for you would be if you would want to learn Apache Flink, right, and try Ververica Cloud as well.
Alexey, I wanted to invite everyone to our upcoming Berlin Flink Forward for 2024. Our registration is going to be opening soon. It's also going to be in October of this year. So we'll definitely be getting some additional information from us with regards to this. But if you're interested in talks like this one and others that dive into technology deep dives around Apache Flink and all things streaming data platforms, that's going to be a place you'll want to be as well.
Yeah, welcome everybody to Berlin this year. So it's going to be quite fun. All right, so
I think last on here, Alexey, I'd really like to thank you for all of your expertise in directing this webinar and also creating kind of a very interesting use case that we can definitely use in a couple different ways regarding Apache Flink using Ververica Cloud. That was really helpful to see. If anyone has any additional questions, please don't hesitate to reach out to us. We'll be sending an email that will have the source code as well as the recording of this presentation. And as Spencer mentioned at the top, all of those resources will be provided out also. Again, if you've got any questions, please don't hesitate to reach out to us. We're happy to help.
Thank you guys for helping me. Yeah, thank you for all attendees.
Of course. Thanks, everyone. Have a great
Go
day.
bunnies.
Have a great day.
Bye all.
Goodbye.